Morning student. Today we will try to solve some problem on air compressors. Let's have the first problem. A single stage air compressor is required to compress 60 meter cube of air from 1 bar to 8 bar at 22 degrees centigrade. Find the work done by compressor if compression of air is isothermal, isentropic, and the polytropic. So under three processes we need to calculate the work done by the compressors. So if you go through the problems, you'll find the data is given as V1 in initial conditions, volume is 60 meter cube, initial pressure is 1 bar, and the initial temperature is at 22 degrees centigrade, and the final pressure is 8 bar. So first let us consider the first process when the compression takes place isothermally. We know in the isothermal process the work done will be given by P1 V1 ln P2 by P1. If you put the value the work done will be come out as 12.48 megajoule. When we consider the isentropic process, the formula is gamma by gamma minus 1 P1 V1 within bracket P2 by P1 gamma minus 1 to the by gamma whole minus 1. So if you put these values in the formulas and calculate, the value will come out as the work done value will come out as 17.04 megajoules. And for polytropic process, gamma will be replaced by n, the rest will be same, and if you put all the values, the answer will come out as 15.47 megajoules. Let us take the second problem. In this problem, we need to find out the power. Find the power required to compress and deliver 2 kg of air per second from 2 bar and 20 degrees centigrade to a delivery pressure of 16 bar when compression is carried out in single stage compressor. The compression follows the law PV to the power 1.4 is equal to constant. If you look into the problem, you'll find that mass flow rate is given as 2 kg per second. Initial pressure is 2 bar. Initial temperature is in Kelvin scale 293 degrees centigrade Kelvin, 293 Kelvin, and the delivery pressure or the final pressure is 16 bar. So we know that work done is equal to gamma by gamma minus 1 into P1 V1 into within bracket P2 by P1 whole to the power gamma minus 1 by gamma minus 1. Now if you look into the formula, the V1 is not given in the questions. So we know gas equation P1 V1 equal to AMR T1. AMR T1. The value of R for air is 287 joule per kg per Kelvin. Now if you put these values in the equations, you will find the work done is 477,648 joule per second. So joule per second means this is the work done per second. So work done per second is nothing but the power. So power is equal to 478 kilowatt. Let us solve the third problem. It is given that an air compressor takes in air at 1 bar and 20 degrees centigrade, and compression takes place according to the law PV to the power 1.2 is equal to constant. It is then delivered to a receiver at a constant pressure of 10 bar. And we have to determine temperature at the end of compressions. Number 2, work done during compression per kg of air. If you go through the problem, you will find the initial conditions are given. Pressure P1 as 1 bar, temperature as 293 Kelvin, P2 10 bar. If you draw the PV diagram for the whole compression process, it will look like as shown in the figure. The process 1 to 2 is the compression process following the law PV to the power 1.2. So it's a polytropic process. The compression takes place polytropically. The initial pressure is P1 and the final pressure is P2. First part, we have to find the temperature at the end of compressions. And we know for polytropic process, the relations between temperature and pressure is given as T2 by T1 is equal to P2 by P1, n minus 1 by n. The initial temperature is given, final pressure given, initial pressure given, initial temperature given, final pressure given, initial pressure given, value of polytropic index is given. So if you put this value, you will find the final temperature, that is at point 2 or state 2 is equal to 430 Kelvin. Let us solve the next part, that is work done during compression per kg of air. Already we know the formula, work done is equal to n by n minus 1, P1 into V1 is into P2 by P2, P2 by P1 n by n minus 1 P1 V1 into P2 by P1 n minus 1 by n minus 1. So we need to find out, since we need to find out the work done per kg of air, so P1 V1 will be replaced by AMR T1. So work done per kg of air is equal to n by n minus 1 RT1 into P2 by P1 n minus 1 by n minus 1. If we put this value, if we put the values of R, which is for air is 287 joule per kg Kelvin, temperature 293 Kelvin, the answer will come as 236 kilojoule per kg of air. Thank you.